If you're a beginner to programming, learning to read the documentation is the most important skill you'll need to learn to be able to start to write code on your own. Tutorials will keep you afloat for a little while, but you'll only start to grow as a programmer when you learn how to fetch information on your own and write code that belongs to you. Trust me, your pace of learning will grow exponentially when you learn how to learn. We'll be looking at some practical examples and a bonus feature at the end, so stick around for that. There are two main sections in the Godot docs. If you didn't know already, let me introduce you to Emmanuel. The manual. The manual is where you can find written guides on specific topics relating to Godot, game development, and anything related. You can get to it by searching for the Godot docs online and expanding the manual section on the left. It's often a very overlooked part of the documentation, and most people don't know it even exists. If you're ever looking to tackle a new concept, the manual is an excellent place to start looking. It may not always be fully comprehensive, but it should give you a good starting point to base your research off of. I've tried to just go through it starting from page 1 before, with the intention of reading the whole thing, and I was able to pick up a lot of little tidbits that would have been really difficult to find from any other sources. But I'd be lying if I said I lasted long. It's by no means a fun activity to understand Emmanuel, but again, just from the few sections I got through, I was surprised to find out how much valuable information was freely available, just lying there. I'd recommend trying it out yourself and seeing how far you can get. I think you'll find some value even if you just get through a couple of pages like I did. But if your sheer willpower is suboptimal like us average human beings, then you might prefer to refer to it on a case-by-case basis. As an example, let's say you discovered the phrase static typing for the first time somewhere, and you have no clue what that even means. That's okay, because the manual has a page for that. I wonder if I can export all these special input fields that the editor uses for my own script properties. You're new to something. What is it? Writing to files? Working in 3D? Vector math? Multiplayer? Whatever it is, the manual has you covered. You're going to have a solid introduction that will help you gain a base level of understanding, which is infinitely better than starting from scratch. It won't turn you into a master at all those subjects, but you know what will? This video sponsor Skillshare has you covered with their large selection of classes on a wide range of topics ranging from drawing, animation, video editing, game development, writing, productivity, and what's this? Gardening? Woodworking? Cooking? Okay, stop, I'm running out of fingers. You've heard of Skillshare. It's the largest online learning community for creatives with thousands of classes led by industry experts. Whatever skill you're keen on learning, whether it's for your career, hobbies, or passions, Skillshare can help you take it to the next level. I personally have been eyeing Ali Abdal's class on how to organize your workflow and maximize productivity, because I love finding ways to optimize my time out of tasks wherever possible when I'm making these videos. And if there's one thing I like more than making videos, it's to do less of it. Was that on the script? The first 500 people to use the link in the description will receive a 1-month free trial of Skillshare. Even if you work on a skill for 1 hour a day, that's 30 hours of free classes. So, what are you waiting for? Anyways, back to the video. The second section in the docs is the class reference. This is the section you should be referring to all the time, way more than the manual. This video will focus on learning to read the class reference. This section is commonly referred to as the API. You can think of it as a dictionary. Let's say you come across a new word today that you want to learn the meaning of. What would you do? You'd look at the dictionary. No, what are you, stupid? You'd Google it. But let's say you were born 120 years ago, you'd be dead. You'd look at a dictionary. You'd look for the first letter of the word, second, and so on until you find the page that contains the definition for that word. That's similar to how you'd use the class reference. Every single engine class has a page in the docs that contains a description of the class and lists out all the attributes that belong to that class. One great thing about Godot is that it has its API accessible right from the editor, but you can also find it online if you prefer. Everything I'll be discussing will be applicable to both of them. I'll discuss all the ways you can access the docs a little bit later. When you open the page for any class, the title you see up here tells you which class the page you're in belongs to. You can also see it in the script list on the left. The main 3 things to pay attention to when you're in the docs page of any class are the inheritance hierarchy, properties, and methods. The properties section is a list of all the property names, along with information about each property's type and what the default value is. This is the value that the property is initialized as when you create a fresh instance. The types and names of the properties are all clickable links. Clicking on the type takes you to that class's page, and clicking on the name takes you to that property's description within the same page. Every single property that you see in the inspector can be accessed through code, and you can find information about those properties in the docs. The inspector displays the property name in title case, but if you refer to it that way in code, that won't work. If you look at the list of properties, you'll see that they're all displayed in snake case, because GDScript uses snake case for its properties, and this would be how you'd refer to them in code. Any property you see in the inspector can be get or set through code by accessing it in the way I just described. But these are not the only properties that the class contains. The class may contain a lot of other properties that are not visible in the inspector, so it's always a good idea to skim through the docs to see what you have available. An example in the Node2D class is the global position property. It's not displayed in the inspector, but you can access it through code. It's also important to know that the name of the property displayed in the inspector might not always match the actual name of the property. An example of this is the mouse filter property in the control class. It shows up as filter in the inspector, but if you try to use that in code, then it wouldn't work. Only by looking at the docs, we know that the real name of the property is actually mouse filter. To reliably know the name of a property, you can either simply hover over the name of the property, which will show you the real name on top, or you can right-click on it and press Open Documentation to go to the description of that specific property. Note that if you were coding in C#, you would need to look at the name listed in the docs, but use it in Pascal case to follow C# conventions. The property descriptions section contains descriptions for all the same properties that are present in the list above. Clicking on any property name in the list above takes you to its description. You'll see these setter and getter methods for most properties, but you can ignore them for the most part. They're only used for niche use cases, and 99% of the time, you're better off directly accessing the property itself to get or set it, unless you're weird like that guy. If you ever don't know what a property is or does, or you're having trouble with getting it to behave properly, then the first thing you should do is look at its property description. There might just be something really simple that you're missing. An example of this is the rotation property. Say you want to rotate this node by 90 degrees through code, but when you set the rotation to 90, the result is completely different. So what would you do? You'd Google it. No, what are you, stupid? You'd look at the dictionary. When you look at the docs for that property, you'll find out in 7 seconds that the units it's expecting is in radians and not degrees. And by doing this, you'll also quickly learn that it's actually displayed in degrees in the inspector, but it's internally using radians. And you'll also know what to do if you want to use degrees. You've gained all this information by simply right-clicking on the property. Now compare that to Googling a question, seeing if someone else had the same problem as you, looking through multiple Reddit posts and forum pages until you find out that the issue was due to some random, seemingly arbitrary rule. I hope you're seeing my point. You can of course Google it to get to the same conclusion, but the docs are much quicker. I'm not saying that the docs will have all the answers you're seeking in life, but they really should be the first place you should start looking. It'll save you so much time and effort. Next we have the method list. The term method is just another name for functions. There's a surprising amount of information on each item in the list here. Let's break it down. Let's take a look at the addChild function for instance. The signature of the function gives us a lot of information. It has 3 sections: the return type, the name of the function, and the parameter list. The name is obviously how you'd refer to the function, the parameters are what the function takes in, and the return type is what it spits out. In the parameter list, some functions may have some parameters that have values assigned to them. These are known as optional parameters. You need to pass in arguments for all the normal parameters as usual, but you can choose to not pass in values for the optional parameters. If you don't, they'll be set to these values by default. In the case of addChild, in most cases I'd call it by passing just one argument, and the other 2 parameters would have the values false and 0 by default. But if I wanted to, I could pass in additional values for one or both of those parameters. I'll talk about this keyword here a little bit later. I'll store it here in my basement so it's safe and sound. What? It's dark in there? You're feeling cold? You'll be fine. The method description section, similar to the property descriptions, contains details about the same methods mentioned in the list on top. Clicking on the method name in the list above takes you to the relevant description. The text highlighted in blue refers to the parameters of the function, and they're usually used to describe how that parameter's value affects the behavior of the function. Again, in C# you'll have to use Pascal case instead of snake case for methods and most other things too. Every node in Godot extends the node class. This means that any child class will inherit all the members that the parent class contains. This is the reason you're able to call a function like getNode or addChild on a Node2D or a control, for example, since they both extend from the node class which contains those methods. You can visualize the inheritance tree by looking at the Create New Node window and paying attention to how each node is nested. Node is the root node type of all nodes, so everything else is nested under it. If you expand it, you'll see everything that directly extends it. And you can keep expanding sections to see what directly inherits what. This hierarchy actually goes further than nodes. It has nothing to do with nodes specifically. It's just that they're a part of a larger hierarchy of non-node classes too. The inherit section at the top of the docs page shows you all the branches of the inheritance hierarchy that lead to this node. Taking a look at the collision object 2D class, we can see that it inherits node 2D, which inherits canvas item, which inherits node, which in turn inherits object, which is the base class of all objects in Godot. It basically lists all the parent and grandparent classes up the tree in the hierarchy. The inherited by section lists all the nodes that extend this node, that is, any direct child classes down the inheritance hierarchy. All of this effectively means that this class inherently contains all the members of the parent classes, and all the members of this class are accessible to any child classes. Due to this reason, you might not always find members that you'd assume would exist in a class. You'd also have to remember to check the parent classes to see if they have it. Whenever you ask yourself what you can do with a particular node or class, what would you do? You'd open up the docs. Say you're looking at a button node and you want to run some code when the button is pressed. Presumably, the button docs page would have something relating to pressing the button, right? Nope. This is a really common pitfall. When you hit a dead end like this, it's a good idea to look at what classes this class inherits. We can see here that the button extends the base button class, which sure enough, contains the press signal as well as the pressed virtual method. We can look into the details of each of those to decide which one we want to use. Speaking of virtual methods, any method that contains a leading underscore is considered to be a virtual method. What this means is that you wouldn't just call these methods like you normally would for them to work. Godot expects you to override them and define your own custom logic in them. These methods will be automatically called for you, and your overwritten logic will be executed. Think of all the basic cycle methods you've been using, like ready and process. You're not actually defining new functions when you do this in code, even though the syntax looks like you are. You're actually just overriding them and providing custom code to be run whenever the engine calls this method. The leading underscore on methods is just a GDScript naming convention to communicate the fact that the engine will handle calling it, and that the method's primary use case is to be overridden. Let's have a look at the property list again. Sometimes you'll see a yellow comment next to a property that says overrides. This refers to the default value of that particular property being different from the default value defined in the parent class. You'll see this pretty often on classes that extend control. For example, if you look at the docs for the base button class and look at the toggle mode property, it's set to false by default. And when we look at the check button class, it tells us that the default value is overridden to be true instead. So when we create one and look in the inspector, it is in fact true by default. Huh? What was that? Hey there, buddy. Who put you in the slightly damp, dimly lit, questionably scented, spider-infested basement? That's so horrible. I mean, not even the spiders look like they want to be here. Who would do such a thing? Come out here, you'll be safe with me. Who are all these people? They're here to watch you. What do you mean that's weird? This gray text next to a method is known as a qualifier. It's a label that gives us information about the nature of the method. There are a couple of different qualifiers that you'll see when looking through the docs. Let's look at each one. The static qualifier on a method means that you don't need an instance of that object to call the function on. This means that you can call the method on the class name directly. For example, the node class contains the method printOrphanNodes. Normally, for most of its non-static methods, you'll need an instance of a node to be able to call them. However, since this function is static, you'll be able to call it on the node class name directly without needing an instance at all. Note that some classes are singletons. It's usually mentioned in the class description if it is one. In that case, all the members in the entire class would need to be accessed on the class name directly. An example of this is the input class. You use the class name to access its members directly. You can go to the docs page for @globalscope to see a list of all available singletons. Virtual. We've seen virtual before. All virtual methods are named with a leading underscore to easily identify them. They usually exist only to be overridden. They don't do anything on their own, so you wouldn't call them like normal functions. You'd just declare one as if you're creating the function and write some code. Godot will handle calling it for you. Just make sure you're declaring it with the correct signature or you'll get an error. The name of the function also needs to match exactly. In C#, you would have to use the override keyword and treat it like any other virtual method. Vararg stands for variable arguments. It basically means that you can pass in an unlimited number of arguments into a function. Usually a function tagged with this qualifier has some information in the description about what the additional arguments would be used for. For example, in the object.call function, we see that it takes in the name of a function, and additional arguments of any type can be passed in, which would be passed through to this method. The const qualifier tells you that the function does not modify the object you're calling the function on in any way. The function does some operation without changing any properties on that instance. For example, the toGlobal method in Node2D simply takes in a value, does a conversion, and returns the result, without modifying any data on the Node2D that you called the method on. Contrast that with a function that does not have any qualifiers listed on it. The rotate method, for example, sets the rotation property of the Node2D you call it on, so it does modify the object. You can always hover over any qualifier to get a tooltip about it, if you forget what it means. That's all about qualifiers. Let's move on. You can get to the docs in a bunch of different ways, and knowing all of them will make you more efficient. No competition, the best way to search for any entity in the docs is to press F1 on your keyboard. This opens up the docs search window. This is the quickest way to get to what you're looking for. or to search for keywords to check if something you're looking for even exists. When in doubt, press F1. It should be the dirtiest key on your keyboard. You can look up any class, property, method, or pretty much anything else, and locate it in the in-engine docs, without leaving the editor. You can hover over any property in the inspector to see its description, and you can right-click on it and open documentation to quickly navigate to it in the docs. Hovering is convenient when you need to take a quick peek at the real name of a property and get a brief understanding of it quickly. You can also use the docs button here to go to the selected node types page. When you're inside a script, you can hold Ctrl and click on any symbol to automatically navigate to its definition in the docs. This also works with any type of symbol. It's important to remember that it will only work consistently when you statically type your variables. Say you create a dynamically typed variable and call a method on it. Godot doesn't have enough information about what object you're working with, so control clicking on it might not do anything. But when you static type the variable, you can reliably control click on it to go to the docs. Those are all the ways to access the docs. Let's move on. Huh? What was that? The docs website? Don't even bother. The stupid search bar on the website is somehow slower than Unity reloading a domain the second I sneeze anywhere near my own code. You're better off using the in-engine docs search, which updates the results live while you're still typing. Anyways, moving on. The enumerations section lists out all the enums present in a class along with each of their values. These enums are usually used by properties and functions in the same class. For example, the process mode property in the node class is of the enum type called process mode. So if I wanted to set its value to process mode disabled, then I would need to use the enum name and then access a specific value on it, and then assign it to the property. The constructors section shows all the possible ways to construct a new instance of that class. Correct me if I'm wrong, but I believe this section only exists for the base primitive types, and not any other class pages. For the vector2 class, we can see that all these variations are valid, so we can construct a vector2 in any of these forms. The constants list shows you all the named integer constants defined in the class. The signals list shows which signals are available, and the signal signature gives you information about which parameters it contains. You'll have to make sure that you declare the same parameters in your signal handler methods. Whew, there you go. That's all you need to know to understand how to read the docs. You thought the video was over, didn't you? Nope. You now know how to read the docs, but how should you approach learning from it? Anytime you're introduced to a new class and you want to learn how to interact with it, a good place to start would be to open up its docs page. Just skimming through the property, method, and signal lists should give you a top-level view of what the class is capable of. Take the input class for example. Even if I've never used it before, by looking at the description, I'm made aware of the input actions and something known as the input map. From the method list, I see that you can manipulate those actions in some way. I can get information presumably about connected controllers. I can check if an action is pressed or released, and so much more. And I can always look into the descriptions if I want to learn more about what a function does. This is a really important skill to cultivate. When you start getting comfortable with doing this, you'll no longer find the need to look for a tutorial that exactly matches what you want to do in your own projects. We'll walk through some practical examples together on how you would use the docs to learn something new. Let's say you need to figure out how to set the size of this Area 2D's shape from a script on the Area 2D. If you don't know how to do it already, attempt to figure it out on your own. If you get stuck, then you can follow along to see how to approach it. Okay? The way I would approach it would be to first look at which property I want to get a hold of. I know that the collision shape 2D node defines what shape to use and its properties, so I'll look there. When I change the size of the shape in the editor, I see that the radius property changes. So my goal is to access and set this property through code. The next thing I do is find out where that property exists. It's inside the circle shape 2D resource. I can look at that class's docs to make sure. Now, where is the circle shape 2D located? It's in the shape property of the collision shape 2D node. So I'd have to get a reference to the collision shape 2D node first, access its shape property, and then finally access the radius property to be able to set it to a new value. Another example. Let's say you wanted to interact with an items list node. Make one with 3 items and give them some text. The exercise is to make the second item disabled and then change its name to something else. Have a go at that. This one's a slightly tricky one. If you've never worked with the items list class before, don't worry, that's the whole point. It's to learn how to work with classes you've never even heard of before. Alright, so the first thing I notice is the fact that the items don't seem to be stored in a property at all. They all show up under this heading, but that's not a property. A bit weird, but okay. Let's open the docs. When I skim through the method list, I see that there's a lot of methods to get the attributes of an item. Doesn't seem like the item is an object at all. When I keep going, I also see that there's a bunch of methods to set an item's attributes. First, I want to set the item to be disabled. This list is massive, I can take an educated guess that the method name would have the word disable inside it. So I can press Ctrl F to search in the whole page and type in disable, and sure enough, I see a couple of matches. I can go through the matches to find the set item disabled method. Looks like it takes in an integer index, presumably to tell it which item I'm referring to, and a bool for the value I want to set it to. Perfect, that's all the information I need. I can then use the same approach to figure out which function I need to use to set the text, and there we go. Being a good programmer doesn't mean that you know how to do everything. That's impossible. No one knows everything. It's all about knowing how to work your way through anything you don't know. And like I said, the class reference is basically the same as a dictionary. You're not expected to read through the whole thing and learn it. All you need to know is how to look for the information that you're lacking. If a tutorial you're watching uses a method or property that you're unfamiliar with, then you shouldn't just copy it without knowing what it does. Then you would learn nothing from it. The least you can do is look it up in the docs. And you learn so much just from doing that alone. I'm not saying that you should try to understand everything down to the smallest detail and only then move on. No, sometimes the functionality of some methods and properties are a bit above our skill level, and it's completely normal to not fully understand everything you're using. But just the mindset of looking up everything to at least get a brief idea of what you're using will take you so much further than just copying the tutorial. If you ever wonder if a class can do a particular thing, press F1, search for the class, press Ctrl F, and try to find keywords that relate to what you're looking for to narrow down your search. Since you made it this far into the video, here's a bonus for you. Did you know that you can have your own script members be displayed in the in-engine documentation? A single hashtag is used to write comments, but you can use two of them to create documentation comments. Godot will automatically create a page listing all your class members in the exact same format as its own docs. It's really convenient to be able to look up all your class details in a neat format. You can access your custom docs through the F1 menu. Visit the GDScript documentation comments manual page for more information on how to format your custom docs. And now, here are a few spicy tips to help you with your workflow a tiny bit further. You can use the middle mouse button to quickly close tabs in the script list. The script list gets pretty messy when you start opening a bunch of docs pages, so you can go into the editor settings and set a keybind for the close docs action. This way you can declutter your list to just see your scripts again, without having to do it manually. You can use the headings list below the script list to quickly scroll to different headings in the docs. It seems obvious, but it's hidden in plain sight. And when you start using it every time, it makes navigating the docs a lot nicer, especially on some of the longer docs pages. In the F1 menu, you can filter the list to only show a particular type of symbol, which is sometimes useful if you're looking for a keyword that's present in a lot of different types of symbols, but you only want to look for a method, for example. Use snake case when searching in the F1 window. You could also just type it in with spaces, but it doesn't automatically highlight what I'm looking for, so I prefer to use snake case, and just hit enter when the correct one is highlighted. And just a reminder to not forget about the manual. It has so much useful information. In fact, it even has a page on how to read the class reference. There you go. You could have made this damn video yourself. If you want to learn 100 new Godot tips to speed up your workflow, you should watch these two videos. If you learned something new from this video, I'm sure you'll learn a lot from those two. Anyways, thanks for watching. See ya.